Morning, everybody. It's a pleasure to be here. Extremely well. I don't know if that's the right adjective or not, but thank you nonetheless. Vanessa did not tell us what everybody else's unique fact was, so I hope mine is mildly intellectually stimulating compared to the others. I should have thought that through. So what I'd like to do today is just spend a few minutes talking about Faro. I think we're a relative newcomer to many of you relative to this space and this group, so I'll just talk for a couple of minutes about how we got to where we are today. And a lot of time asking some fundamental questions about visualization, utilization of 3D technology, and things that we ask ourselves internally all the time. And because it's a session that is meant to be tied to visualization, I've tried to make this as interesting as possible as it relates to some of the work that we're already doing today and where we feel a piece of the industry should be transforming to. And what you'll see is that we play a very specific role in this space. We don't cover everything in this space by any stretch of the imagination. Our role is very specific to the technology that we develop. So let me just talk briefly about who we are. So as mentioned in the introduction, we're the world's most trusted source for 3D measurement, imaging, and realization technology. The company's been around for 33 years. A lot of people in the space may not know that, but we have industrial roots that go back to 1981. We've been publicly traded in the United States for about 17 years now. We have a significant global footprint to be able to support all of the customers that we have around the world and great financial strength. And as mentioned, we were named one of the fastest growing companies by Fortune magazine last year. We are a major player in the 3D ecosystem. Again, this is a newer portion of the space for us, for Faro. The industrial side we've been doing forever. And that global support footprint has been built up over the years. So if you look at where we have service centers, where we have manufacturing, and we have responsible locations around the world, we have a sales presence in more than 25 countries, which have put our products into the hands of customers in more than 50 countries now. So we have a continuously building presence here to support everyone out there. And it has allowed us to develop a very strong world-class customer base, and the technology that we've used to develop that is portion of what has now been migrated and moved into the space and the area that we're talking about here today. And we see ourselves as a disruptive innovator in space. That's one of the things that is core to the people at Faro, is that we always want to be on the front end. We're always challenging where we should be going next and challenging where the markets that we're in we believe should be going next. And so you'll hear a little bit about that today. So when we take that mission statement, if we take it and we break it down to the core fundamental elements of imaging, realization, and measurement, there's really two key areas that we play today. The first one is one that you're probably much less familiar with, which is the metrology world, and the science of metrology, which is precision 3D measurement at high levels of accuracy. You're into the micron levels of accuracy, and it is predominantly an industrial game. And if you look at where our technology is used today in the metrology world, it is all over the major industries you might imagine. Automotive, up and down the automotive industry and the supply chain. All across aerospace, so Airbus and Boeing and Bombardier and all of the supply chain that's a part of that, all of the engine manufacturers. The ability to reverse engineer in high precision, so taking complex parts and creating your first CAD models in minutes or hours instead of taking weeks or months when you're designing something from scratch. That's an area that we play, that's technology that we leverage into the geospatial side now that we're talking about today. We can measure extraordinarily small parts. We can measure some parts that are highly unusual. Those are things that people don't necessarily expect. Here's a great example. We love to show this one in the United States. Jay Leno's a relatively famous entertainer. The purpose of showing this image is to show the amount of data, the density of the data that can be collected at high accuracy. This is 50-ish microns of accuracy, so fractions of a human hair of the entire facial structure of Jay. That was captured in about 3 minutes of scanning time with the Faro laser line probe that is used in the industrial world and obviously is not just used for industrial purpose. Now most people here would say, okay, that's very interesting, but the part that we all really came to look at is what we call documentation, so the 3D documentation side of our business, and it's the part that ties directly into the geospatial world. So 3D documentation for us is delivering millimeter level 3D measurement, imaging, and analysis. So we want to deliver good quality, high density points in full 3 dimensions to all of our customers for use then in however you are deploying that data and using it around the world. And so for us, we look at that and say the markets are almost limitless. And not surprisingly, I have a list that looks very similar to Brim's earlier today when we think of just a few of the verticals that we're already serving today. Faro is a direct player in this space. Everything from architecture and engineering and construction to mining to tunneling. We've got a great BIM example that I'll show in a few minutes. But these are all the verticals that we're in and where we take our technology today. Now, we do this with two primary devices. Most of you are probably familiar with scanning devices, and hopefully you've heard a little bit about what Faro does with the 3 laser scanners. But our devices really have transformed the industry in terms of portability, ease of use, range of up to 330 meters now in a single scan with our devices, accuracy in the range of 1 to 2 millimeters, full color, embedded GPS, extraordinarily lightweight, easy portability, ease of use. Don't need a laptop with you in the field. Single touch screen, you can watch your scans, you can visualize your scans as you take them. SD data card to simply take your scans out and bring them back to the office. All of what we've done is meant to be driven towards the portability, the ease of use, and the ability to capture simply full 3D data points at high levels of accuracy in the geospatial world. Of course, along with that comes a very comprehensive set of software, which allows you to do all of the different modeling and the characteristics you might need or the applications you may use day in and day out. It comes with an app store that gives you access to all the different applications that you might need in your day-to-day life. And as we continue to grow in this space, you'll see us continuing to add applications that are specific workflows to very different project levels of analysis. And it will include things like Faro Web Share. So this is our cloud-based server that allows you to actually manage your products online with all the three-dimensional data. So millions and millions of individual 3D data points, the full point cloud of all of the projects that you capture, being able to use that real time and share it around the world and collaborate with all of your partners, all of your colleagues, all of your customers themselves. We have that ability today, and we do that today for our customers. Here's a great example, and this is clearly in the industrial side of visualization, but here's our customer at Volvo. They have scanned almost all of their manufacturing facilities now, and in using the web share capability, they have a handful of laser scanners. They have hundreds of individual users on Faro Scene Web Share today, accessing that data, using the data to be able to say, what does the manufacturing floor look like in plant X? How do I replicate that particular manufacturing line in plant Y? Or what does the infrastructure look like in plant X, and how do I replicate that in plant Y? Very, very powerful tools. So now, Faro, when we thought about the question of what the topic was going to be today, this visualization to industrialization, the way I think about it and the way we think about it is democratizing the ability to capture and document in 3D. That's what Faro is all about. And so the way we look at it is say, well, number one, everything in the world has 3 dimensions. I mean, everything, the sheet of paper in front of you all the way up to the complex structure of the building itself, everything has 3 dimensions. And when we look around the world and we look at all of the structures that are out there and the need to capture and have not just individual data points, single point here, single point there, but the ability to actually capture and visualize that facility in full 3D, that's how we think about the space in the world, and that's why the scanning side and the delivering these great quality points to everybody is what we think about it. And so the need to continue delivering that detailed information keeps growing. All of you understand that and know that. And so we still look at it and say, well, why does everybody still have elements of the work that they do in 2 dimensions? Why isn't everybody working in 3 dimensions? Why are we still working with single point-to-point measurements in the world when everything can be done in full 3D in a fully visualizable element? And that's what we're here to talk about. So we have spent a lot of time trying to democratize laser scanning. That gives you a feel for just how small and lightweight the devices are that we have in the marketplace. And we're just getting started. So the ease of use, the low price point, the ability to take this anywhere with you is just the tip of the iceberg in terms of where Faro is headed and where we're going to take the technology as we go forward. For us, it's all about process efficiency, being able to go out to the field in a single visit, not have to go back a second time or a third time because you have all of the data you need on the very first visit. The ability to capture in full 3D and the ability to model and visualize easily in 3D is all of what the technology is capable of. And so what I thought we'd do is just talk through, here's some of the projects that we've worked on with our customers over the last few months, and just give an example of just what that power and capability is. So here's a famous structure that I think virtually everybody understands, the Tower Bridge. You can see the laser scanner in the foreground, and the first image there, that's a single scan off that laser scanner. That entire image is accurate to a couple of millimeters. It is made up of an entire point cloud of individual 3D data points, not unlike the pixels in your photograph. Here's the second scan from under the bridge that starts showing you the level of detail that you're able to capture. This particular project, at 244 meters long and 65 meters tall, it was 3 scans in 1 hour, and the bulk of the scanning time was actually spent walking from location to location, not the scanning time itself with the device. And being able to take all of that back to the office and then use it for creating the as-built documentation that the customer is looking for is a fantastic amount of power for the customer. Here's another one. This is a cathedral in France. You can see the Faro laser scanner there off to the left. This is the outputting data from the sets of scans that were done. So again, full visualization, all in 3D at high accuracy. This particular project is for a building renovation. They were identifying cracks in the facility and the structure itself from a storm. 2 people, 19 days, only half a day, or 19 scans, only half a day to capture all of that data and put it into full 3D format. This is a famous tower over in Russia. It goes all the way back into the 1940s, I believe. Here's the scanner going up the scaffolding, up the ladder into the top. So again, showing that portability, the ease of use, and the ability to set that up and then capture the entire tower in 3D. You can do the overhead views. You can go immediately to your modeling. And so from our standpoint for this historical preservation project of a 90-year-old artifact, 100 million 3D data points captured in just 3 days with a single person climbing up and down and doing the scans and moving the scanner around there. Here's one on the piping side. We all understand how complex piping facilities can be, energy facilities can be, petrochemical facilities can be. There is the photograph prior to the scan. There's the scan itself. Every single one of the elements in there is in full 3D. Single scan right there. Over this project, also the ability to immediately load in and match up your CAD models, overlay it with the point cloud data that's there. For this particular project, this was a deep water drilling well off the coast of India. So they were able to install new pumps and replace a whole series of the high pressure drill piping. They did 107 scans of this particular facility, and they only did it in 2.5 days. And the savings for the customer was, because of the amount of detail they were able to capture, all of the piping, everything they were able to pre-weld before going into the facility saved them $1,000 per pre-weld. This was hundreds of thousands of dollars saved in this one particular project by avoiding that work on site and doing it in advance of coming out to the offshore well. And then a couple more that we like to show. Here's a facility, a bridge in Germany. You see the scanner in the foreground there. There's the first set of scan data coming out of it, so capturing the bridge, the entire surrounding area. This was a 900-meter span, 50 meters above sea level plus another 100 meters of height. We did 15 scans in 4 hours in full color to create that 3D model and the visualization capability that goes with it on that project. So the laser scanner, the way we like to think about it, is all about empowering the users, empowering everybody who's in the field. And the question we're constantly asking is, why isn't everybody scanning in 3D? Why 3D part of the specifications that the policymakers are putting forward for every single project? I want to visualize the entire project in 3D. I don't just want to see your cutaways. Look, I can do architectural cutaways for sure, but what else can we do with that data? Why isn't that part of the spec? You want to put this on a car and drive at 50 kilometers an hour and scan the city and capture the data along the way? We can do that. That's captured in full 3D, running at 50 kilometers per hour. Those images coming off the device there. You want to do the entire village? You can do that. You can do the entire city. That's the power of the technology. And when we think about visualization, why aren't we thinking about all of our projects in that way, shape, or form? You want to automate it, put it into your facility, and teach the device to scan one time and then just replicate to the various scan locations so you don't ever have to touch the device again? You can do that today too. Again, tied back into the industrial side, the visualization that goes with it, the asset management that goes with it, the pre-planning for your facilities that goes with it. You want to take it to the air? Yeah, we have customers who are doing that too. They have actually taken the device into the air. You can now do your airborne scanning at lower altitudes, running it off a remote control. This is a fairly, without downplaying the complexity of an octocopter, it's not that hard to get your hands on one today. A lot of people in here may have already seen these and played with these before too. So, and then the last one that I like to highlight, if you're looking for great examples of just what you can do with the technology, I urge everyone to take a look at this. This is a project that was done in conjunction with Google Earth. 9 months at the Palace of Versailles. One of our customers went in, they scanned, I think, over 2,000 different scans. And if you go to Google Earth and you go to Palace at Versailles, you can zoom in and you can explore the entire palace. So from a visualization standpoint, from a consumer standpoint, it's fantastic. From the standpoint of the Palace at Versailles, they now have every single artifact, every single piece of infrastructure that's in that facility. The entire BIM, we talked, was talked earlier today about the power of BIM and why that is so important going forward from an information standpoint. The Palace at Versailles has all of that now in full 3D at their fingertips anytime they want it. And that was in a single project done with a relatively small number of people who spent half their time getting the tourists out of the room so they could scan it as much as they did actually doing the scan themselves. So for Faro, that's what we were all about. So those are the questions that we like to think about. Why isn't everything done in full 3D? It is clearly the enabler for visualization. Why do we still do our measurements today in individual single points when you can do all of it in a single device and in the full 3D that's available to you today? So thank you very much on behalf of Faro. We appreciate the time to be here. I look forward to the rest of the panel discussion and any of the questions over the next days. Thank you.